Welcome back to another video class. There we go. I didn't scare you this time. All right, we have our next video. Today is just like a recap video. Okay, we're putting all the 6 trig functions into one place, and so that we can kind of compare contrast. All right. So we start with sine cosecant. And we know that a sine starts at the middle and goes up to the max, and then back to the middle, and then down to a minimum, and then back for one period. And then if we remember correctly, cosecant is the reciprocal. So anytime you divide by a 0, there will be an asymptote. And of course, we just kind of fill in those parabola-looking pieces, something like that. Okay? So cosecant in green, sine in red. Well, we can do the same thing with cosine and secant. Alright, if we take a look, well, cosine we know starts at either a max or a min. We'll talk about starting at a max and then down to to 0, and then down to a minimum, and then back, and then finally back up to finish off the cycle, one period. And again, when we divide by 0, when we find the secant, when we find the reciprocal, the zeros will have vertical asymptotes. And then we fill in the parabolas. So there's 1/2 over here, something like that down there, and then to finish like that. Alright? Well, tangent, cotangent, we just learned those are a little bit different. Important thing to figure out with tangent and cotangent is what's going on at the start. And remember, tan is y over x. Tangent is y over x. So think about the starting point of 1, 0. Well, when we do y over x, 0 over 1, that's just a point at 0. Which hopefully then leads you to understand when we do x over y, 1 over 0 is undefined, which is why there is an asymptote at the start for that. Okay? But once we know that we have a point, we know that our next key point will be an asymptote, and it will finish with another point, and same thing on the other side, a point. And remember, tangent is always positive in quadrant 1, so it'll look like that. In quadrant 2, it's negative, so it'll look like that. And then we just finish off the graph. Something like that. Okay? Well, what's going on with cotangent? Cotangent is the opposite. Tangent went point, asymptote, point. Now we go asymptote, point, asymptote. Asymptote, point, asymptote. And then we think again. In quadrant 1, we're positive, which means we have to be positive, and then in quadrant 2, we have to be negative. And then we just finish up the graph, the curve. Something like that. Alright, so there is the start of our graphs. Let's kind of think about how they start. We kind of talked about that a little bit. Well, for sine, it starts at the middle, or if you guys remember, I kind of call it that rest point, that point that it's always going back to. Alright, whereas cosine is a max or a min based on the sign of the a value. Alright, tangent is always starting at a point, and cotangent starts with an asymptote. How do we calculate period? Well, sine, cosecant, cosine, secant, those are all the same. If you remember, we do 2 pi, and we divide it by the absolute value of b. And then we just said it's the same thing for cosine, secant, correct? So 2 pi over absolute value of b. What's the difference with tangent and cotangent? Well, now we know there's one full cycle, or one full period, in 1 pi. So now we don't do 2 pi over b, we do pi over b. And same thing over here, pi over b. Alright. How many sections? Remember, it takes a full rotation, one full rotation around a circle to complete a period of sine, cosecant, cosine, secant. So that means that's 4 quadrants, or 4 sections. We know that tangent and cotangent, it only takes half of a circle, or like a semicircle. So that's only 2 quadrants, or 2 sections. So that's why once we have the period, for these 4 graphs, we always divide by 4, and for these 2 graphs, we always divide by 2. As we move down a little bit, which ones have asymptotes? Well, we know that cosecant will have asymptotes. We know that secant will definitely have asymptotes, and that's where? When the cosine or the sine have zeros. And then, of course, yes, tangent and yes, cotangent. We've talked quite a bit about that. And which are the ones that have a domain of all reals, or do not have any asymptotes or any restrictions? Well, that's just sine and cosine. Alright, so let's do a couple of graphing problems just to kind of review and recap, and then we'll pretty much be on the way. Alright, so when I look at this, I realize this is cosecant. I don't want to just think about it as cosecant. I want to think about it as sine to start. Alright, so I rewrite my equation. This is what I'm going to dash, and then it'll help me figure out the other graph that I'm actually looking for. Alright, so for period, we're talking sine cosecant, so we're doing 2 pi, and then instead of dividing by 2/3, I'm going to multiply by 3/2, which those 2's will cancel, and I just get that my period is 3 pi. That's great, because now I know my section very nicely. Just be careful, remember this is sine and cosecant, so I'm dividing by 4, so 3 pi over 4. That tells me then what my ticks are going to be. Alright, let me make that a little bigger. Okay. So now when I tick, I go 1, 2, 3, 4. 1, 2, 3, 4. And I start to label 3 pi over 4. 3 pi over 4 plus another 3 pi over 4 is 6 pi over 4, but I'm going to reduce that to 3 pi over 2. Well, 6 pi over 4 plus another 3 pi over 4 is 9 pi over 4, and that does not reduce. And then when I add one more 3 pi over 4, I get to 12 pi over 4, or just 3 pi, which is exactly what I wanted. And then I go back the other way. 3 pi over 4, negative 3 pi over 2, negative 9 pi over 4, and lastly, negative 3 pi. Alright, we have to make sure that we put our y labels on, and because our amplitude is 7/9, that's how far I need to go up. So I'm going to say 7/9, and then down here would be negative 7/9. And now I'm ready to plot my sine points, okay? Sine is going to start at the middle, so I'm going to start here, and because my amplitude, or my a value, is positive, I'm going up. So I'm going to go up, middle, down, middle, and then I finish up the other side, and now I dash or dot it. I probably should have changed colors. I'm sorry about that, guys. I hope I didn't confuse you too much doing that all in red. Okay, but now I have my sine graph plotted, or dashed at least, so I can kind of see what I'm going to do here. And we remember that because we're talking cosecant, I know that I'm doing 1 over sine. And so that means whenever I do 1 over 0, I'm going to have an asymptote. 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 And then remember, we just kind of make these parabola-looking pieces. Oh, that wasn't very good. There we go. Okay. So there we have it. There we have our cosecant graph. Last thing we need to do is start to answer some of these questions, alright? So domain. Domain, we say, is going to be all real numbers, but we know that it can't be anywhere where there's asymptotes. So I look, my first asymptote that I drew was at 0, so I'm going to say 0, plus or minus, and then it looks like 2 sections, right? And 2 sections is 3 pi over 2. So that's going to be my rule. 3 pi over 2, and remember that n. All right? For range, we know that it's not where the sine curve is, right? We know that sine would be between negative 7/9 and 7/9. Well, range then is everywhere but that. So from negative infinity up to negative 7/9. And then we have to union that with the other, the top side, which is 7/9 to infinity. The asymptotes we have, remember, asymptotes are actually at these x values, so I don't want a not equals to sign. I want to say x equals, and then it's the same rule that we had above for our domain. So 0 plus or minus 3 pi over 2 n. And then if you remember correctly, and if you don't just remember this, just look at the graph. Where does the green cross the x-axis? Nowhere. Okay? So there you have that graph, 7/9 cosecant of 2/3 x. And let's do one more. All right, we have a negative tangent. We can do this. We got this. All right. So we take a look at this graph. I can just think about it as tangent. Please remember that because it is tangent, the period is going to be pi divided by b. And instead of dividing by 5/2, I'm going to multiply by the reciprocal of 2/5, which means my period is 2 pi over 5. And then my section, this is actually really easy. What happens when I divide 2 pi over 5 by 2, right? Because I'm only having 2 sections with a tangent. Well, the 2's just cancel, right? So my section should be pi over 5. Oh, I was a little bit off the paper there. Sorry, guys. Alright, so I draw my axes, not the straightest of lines, my bad. I think that'll work. Let me extend this a little bit more. I need a little extra. Okay, so I know that with tangent I just need 2 sections to the right and 2 sections to the left. Alright, when I label pi over 5, 2 pi over 5, checked, good. Negative pi over 5, negative 2 pi over 5. Beautiful. All right. Please remember now that because I have a negative 12, I have 2 things that I need to do here. First thing I need to realize is that, well, actually, even before I do that, I should get my points and asymptotes. So let's actually do that now. Sorry about that. So because we're in tangent, tangent usually starts at a point, which means it rotates back to an asymptote, and then a point, and then asymptote, point. Alright, now let's think about this. Normally, a tangent curve would go up, right? Like an x cubed graph. But because it's negative, it's going to be flipped. So when we were usually in quadrant 1, we were positive. Now we have to be negative, which means I'm going to have something like this. And remember, I'm going to dash this. I'm going to dash that, and then let's finish this. Same thing. Something like that. Now the reason that I dashed that is because we need to show amplitude. Right now this is technically just negative tan 5/2 x. To make it negative 12 tan 5/2 x, what we need to do is we need to stretch everything by 12. We already took care of the negative, so don't worry about that. But we have to stretch it, which means any point that I had originally should be farther away from the x-axis. So something like this. I know it's not super pretty, but it'll get the job done. And then lastly, something like that. Okay? So I'm a little bit off the paper, but that's something close to what I would be looking for. Okay? Hopefully that makes sense, right? It has to be further away from the green dashes because of that vertical stretch of 12. All right? Now we could answer some questions. Well, domain we know we're going to say all real numbers, but x is definitely not going to be wherever there's an asymptote. So our first asymptote was pi over 5, and then we had to add or subtract. Oop, looks like two sections. Two sections, you can either say, well, this is pi over 5 and pi over 5 and add them, or just say two sections is 2 pi over 5. 2 pi over 5 n. For range, hopefully remember, we're going down forever, we're going up forever. There's never a gap in the y values, so we're at all real numbers. Asymptotes, we actually already did with our domain restrictions, so we're just going to repeat that. X equals pi over 5 plus or minus 2 pi over 5 n. And then zeros, we do have a little bit of work to do. My first 0 was at 0, so x equals 0. And then I have to add two sections again, or 2 pi over 5 n. Alright, so there is all of the information for that graph. Decent looking picture, maybe not the best graph, but it's doable, and I understand what I'm trying to kind of show with the stretches. Alright, okay, so for a quick recap, graph the following: y equals sine x. We know that we start in the middle, we go up, back to middle, down, back to the middle. And we know that we like two periods, so we repeat it on the other side. Okay? For cosecant, what do? Well, we dash what we just drew. Right? And then we make some vertical asymptotes at all the zeros. And we make those parabolas. We make all those parabolas, okay? So something like that. What happens when we move to cosine? Well, the only difference between cosine and sine is the starting point, right? For cosine, we're going to start at a max, and we're going to come down something like that. Not the best, but it'll do. Oh my gosh, I'm struggling today. So something like that. And then for secant, we basically dash what we just drew. So alright. And then of course, again, we have vertical asymptotes at any of the zeros. Any of the zeros have vertical asymptotes. And we make our parabolas again. So here's the first one. And then again, the goofiest part's over here on the ends. Something like that. Okay? Cool. For tangent and cotangent, gotta remember how they start. Alright? Tangent. Point, asymptote, point. Point, asymptote. Ooh, that was a big space. Point. Alright? And we're positive and we're negative. Alright, again, that's just thinking that tangent's positive in quadrant 1 and negative in quadrant 2. Alright, with cotangent, you have to remember, now we're x over y. 1 over a 0, that's undefined. So asymptote, point, asymptote, asymptote, point, asymptote. And then we ask ourselves the same question: where are we positive, where are we negative? Quadrant 1, we're positive, so we have to grab this point, and then we're negative in quadrant 2. So something like that. Alright, last little bit of information, and this is just kind of a review, just to kind of think about here. If we remember back to chapter 2, even functions were symmetric over, well, what's another even function? Like x squared. What is x squared symmetric over? Or x to the 4th? They're over the y-axis. So which of these are even or symmetric over the y-axis? Well, this one isn't, right? It would not flip onto itself. Cosine looks good. Cosine for sure. Not tangent. Tangent would not flip over the y-axis. Oh, secant. Alright, secant would flip over to itself. Alright, so it's the cosine and secant functions that are even functions. And then when we take a look at odd functions are the goofy ones. We have to remember that means they have origin symmetry, or maybe 180 degree spins. So if we take a look here, maybe at sine, if we spin our paper 180 degrees, is it the same? Absolutely. So sine, and it's pair, right? Cosine and secant went together. So sine and cosecant have origin symmetry, or odd functions. And then let's take a look at tangent. If we flip our paper, wouldn't it be the exact same? Absolutely. So we can add tangent and cotangent to our list as well. Alright, so this was just a good recap. Another couple of graphs. Watch me walk through them, and hopefully you guys just feel really, really good about what these functions look like at this point. Alright, so that'll do it for today. We'll keep practicing, and we'll have a quiz coming up, so make sure that you're asking questions if we're struggling. Alright, have a good one.